In this video, I'll show you how to solve the ALEKS problem called predicting bond polarity. In this problem, you're going to be given 3 molecules. Each molecule is going to have one bond highlighted in red, and you are supposed to decide or predict whether or not the bond is likely to be polar. Polarity arises from a big difference in electronegativity between the two atoms in the bond. And so one of the ways we can tell if a bond is polar or not is just by looking at the relative position of the atoms in the bond. Remember that the trend for electronegativity is that it increases as we go up, and it also increases as we go to the right. So if we have two elements that are really far apart from each other on the periodic table, like over here and over here, they're going to have a big difference in electronegativity, and that bond is going to be polar. So we've got a couple of elements in our first molecule, chlorine and fluorine. If we've got a couple of elements that are really close together, then we would predict that since they are really close together, they don't have a very big difference in electronegativity, and that would mean that their bond is not polar. For hydrogen and bromine, if we look at where they are located, hydrogen is over here and bromine is over here. Those elements are super far apart. And so we would say that that is a polar bond. And if it's a polar bond, it wants us to predict which is the most electronegative based on this trend as we go across the periodic table to the right. Then bromine is going to be the most electronegative. The last one that we have on here is hydrogen and oxygen. Hydrogen is right here, oxygen is right here. Again, super far apart. That's a polar bond, with oxygen being the more electronegative of the two. Now, this problem is going to be kind of sneaky because some of these predictions are not going to give you great results. Like, they are just predictions. And so if we go back to this fluorine-chlorine thing, this bond, even though these elements are side by side on the periodic table, it's actually a polar bond. It's not a nonpolar bond. And so that's probably pretty frustrating to you. Like, how would you even guess if you have two elements that are touching each other? Are they going to be polar or are they going to be nonpolar? You can't really make a guess on this at all. You need to do some calculations. So if you want to kind of play it safe and not risk getting this problem wrong, rather than predicting bond polarity, I would encourage you to actually calculate it. It's a super easy thing to calculate. I just went on the on the internet and I Googled periodic table of electronegativities. Let me just I looked for table of electronegativities. I found one that looked like it was pretty easy to read, and that's what I went with. And you can see these red numbers on here. These are the electronegativity values for each one of these elements. And so the kind of the benchmark that we have, if the difference in electronegativity between two atoms is 0.5 or more, then the bond is going to be polar. Now, there are some differences, a little bit of discrepancies in this number. Some people say 0.4, but 0.5 is definitely the most common. And so if we look at chlorine and fluorine on this particular table, we can see that they have a difference in electronegativity of 1. So even though they are super close together, they still have a big difference in electronegativity, and that bond is going to be polar. I would only encourage you to, take the time to do this if you are given an ALEKS, on ALEKS, if you're given a problem or a molecule where the atoms are close together on the periodic table. If the atoms are really far apart from each other on the periodic table, don't worry about it. That's going to be a polar bond, no big deal. But if they're close together, double check on here, or maybe just double check all of them. It doesn't really hurt. And it's a super easy calculation.